All right, today we are going to crack a code. A code that has, let's be honest, stumped a lot of us for ages, the language of algebra. So let's dive right in.
Have you ever looked at an equation, with all the letters and numbers, and just felt like you're trying to read some kind of secret message? Like you're missing the decoder ring or something? Well, you are definitely not alone. For so many people, it just looks like a jumble of confusing symbols. But I'm telling you, by the end of this, that's all going to change. We're going to give you the fundamental tools to see these things not as impossible problems, but as what they really are, puzzles, just waiting for you to come along and solve them. Okay, so every good investigation starts with the first clue, right? And for us, that first clue is asking the most basic question you can about an equation. Is this the right answer? In algebra, we call this first clue a root. So what is a root? It's really simple. It's just a number that when you plug it into the equation for that variable, makes the whole statement true. Think of it like this. The equation is a lock, and the root is the one special key that fits perfectly and opens it. All right, let's put this to the test. Here's our first puzzle. 5x equals 50, and we have a potential key, the number 10. So the big question is, does this key actually fit the lock? Let's find out.
The process here is super straightforward. First, we're going to take our test number, 10, and just swap it in for the x. So the equation now says 5 times 10 equals 50. Now, all we have to do is simplify that left side. And hey, 5 times 10, that's 50. So our equation now reads 50 equals 50.
And there you have it. Click. Since 50 equals 50 is a true statement, our key worked. The lock just opened. So we can say for sure, with 100% confidence, that 10 is a root of this equation. See? Not so bad. Okay, you ready for another one? Let's do it. We've got a different lock and a different key. The puzzle this time is y plus 8 equals 14, and the key we're testing is the number 22. What do you think? Is this one gonna fit? We're gonna follow the exact same steps as before. No curveballs here. We substitute 22 where the y is, so the equation becomes 22 plus 8 equals 14. And when we do the math on the left side, well, 22 plus 8 is 30. So now we're looking at a statement that says 30 equals 14. And yeah, I think we can all agree that 30 does not equal 14. That is just plain false. So what does that mean? It means this key is a dud. It doesn't fit the lock. And we know for sure that 22 is absolutely not a root of this equation.
Okay, so checking numbers is cool, but here's a little twist. You're not always allowed to just, test any old number you can think of. Sometimes a puzzle comes with its own set of rules, its own specific list of numbers you're even allowed to try. This list is called the domain. And a great way to think of it is as the playing field for our puzzle.
So the domain basically sets the boundaries. It's the official list of candidates that are even eligible to be a root. And this is a big deal. If a number isn't on that list, if it's not in the domain, it can't be the solution, period. Even if it technically makes the equation true, it's out of bounds. So for our next couple of puzzles, here's our official playing field. The domain is the set of whole numbers from 1 to 10. That's it. So whatever the correct key is, it has to be one of these numbers, no exceptions. Okay, let's see how this works in the real world. Take a look at the example on the left. The equation is x plus 5 equals 7. Now, we can figure out pretty quick that the root is 2. Is 2 on our list? Yes, it is. So it's in bounds. That's a valid solution. But now look at the one on the right. The equation is 3x minus 1.8 equals 6. The actual root for this is 2.6. And even though that's the right answer mathematically, is it on our playing field? Nope. 2.6 is not in our domain of whole numbers. So according to the rules of this game, this puzzle has no solution we can use. All right, so we've got our keys, the roots, and our playing field, the domain. Now let's talk about the different kinds of puzzles we're going to run into, because not all equations are created equal. They don't all behave the same way. We can basically sort them into two main types. First, on the left, you've got something called an identity. This thing is like a skeleton key. It opens every single lock. An equation like x plus 3 equals 3 plus x, well, that's going to be true no matter what number you plug in for x. Try it. It always works. Then on the right, you have a conditional equation. This is more like our standard puzzle, the kind that has only one specific key that works. It's only true under one condition, like an equation that's only true when x is 7, and that's it.
Okay, now we're getting to the really good part, the powerful stuff. How do we actually find the root without just guessing and checking all day? Well, we do it by using a set of unbreakable laws and, my favorite part, a handful of master keys.
Think of these as the fundamental rules of the universe that keep the whole game fair. First up is the reflexive property. Super simple. A thing is always equal to itself. X equals X. Done. Next, the symmetric property. This just means you can flip an equation around the equal sign. If X equals Y, then hey, Y equals X. Makes sense, right? And finally, the transitive property. This is the if-then rule. If X equals Y and Y equals Z, then it's a no-brainer that X has to equal Z. These three laws are the bedrock for everything else we're about to do.
And with those basic laws locked in, we can finally unleash the most powerful tools in our whole code-breaking kit. I'm talking about inverse operations. These are the master keys I was talking about. They let us systematically pick the lock on pretty much any conditional equation.
So here it is, your toolkit. It's beautiful in its simplicity. Inverse operations are just pairs of opposites. They cancel each other out. If you see addition, your tool is subtraction. If you see subtraction, you use addition. See multiplication, you divide. See division, you multiply. By using these tools, you can strip away everything around the variable until it's all by itself, revealing the root, the answer.
And that's basically it. Seriously, by just getting a handle on these few core ideas, you've gone from seeing a secret language to actually being able to read it. So congratulations! You are now officially an algebra codebreaker.
So let's do a quick recap of the awesome new toolkit you've got. You know what a root is? That's the key. You get the domain, that's the playing field. You can tell the difference between an identity, that always true skeleton key, and a conditional equation that has just one answer. And, most important of all, you have your master keys, the inverse operations that help you find the solution.
So what's the really big takeaway from all this? It's all about the shift in perspective. An equation isn't some scary, intimidating wall anymore. It's a puzzle, a structured puzzle, with rules. And now you have the exact tools you need to take it apart, piece by piece, and confidently find the solution.
You've cracked the first level of the code. These foundational principles of algebra, they're yours now. So the only real question left is, now that you have the keys, what puzzles are you going to solve next?